Hi, I'm Trish Damkroger, VP and GM of the High Performance Computing Group at Intel. Today, as we launch our third-generation Intel Xeon scalable processors, I'd like to invite you to rethink what's possible to achieve with HPC. Right now in HPC, we're demanding more from our systems than ever before. HPC users are running a broader range of unique workloads with varying performance requirements, infusing HPC workflows with AI, adopting new edge use cases, and handling more and more data flowing in from everywhere. So how do we turn these challenges into opportunities? At Intel, we're driving a multi-path approach to accelerated computing. Our portfolio is designed to help you take HPC performance farther, spanning general-purpose compute to specialized acceleration, unique persistent memory, and exascale class storage. Our roadmap is focused on optimizing workloads of every shape and size. And with one API, for the first time, it's possible to develop across diverse architectures with an open, unified, cross-architecture programming model. And Xeon is at the center of it all as a CPU of choice in high-performance processing. Xeon has been the workhorse of HPC for more than 2 decades. In that time, our users have seen generations of innovation, from enhanced vectorization to sub-NUMA clustering to built-in AI acceleration. And today, with the launch of Intel third-generation Xeon scalable processors, we're ushering in a new level of performance and flexibility. Third-gen Xeon scalable processors deliver a massive generational leap in performance for your HPC systems. Take a look at some of the results we're seeing. Applications across the board perform significantly better on third-gen Xeon, like Relion for cryo-EM, and Monte Carlo simulations that financial institutions rely on every day. These gains are thanks to AVX512, along with improved memory latencies and cache sizes. And OpenFOAM, a CFD application that benefits from this generation's increased memory bandwidth. We're also seeing significant performance increases for AI inference workloads compared to our previous generations. And third-gen Xeon will power better performance in the cloud. For example, Oracle Cloud expects to see outstanding gains for their Xeon-based HPC instances. Third-gen Xeon also delivers strong competitive performance gains. Our latest Xeon outperforms AMD EPYC across a range of workloads, including Relion and Monte Carlo simulations, as well as NAMD for molecular dynamics. So what makes this level of performance possible? To speed up diverse workloads with a single general-purpose CPU, you need a balanced mix of capabilities. For jobs that benefit from more compute, we've increased core counts. We've also enhanced L1 and L2 cache sizes and re-architected buffer and scheduler sizes to keep execution units busier, so you can extract more performance from your parallel codes. Xeon is still the only mainstream CPU with built-in AI acceleration, thanks to Intel DL Boost to speed up inference workloads. For applications that rely on fast data movement, third-gen Xeon supports PCI Gen 4 for more and faster I/O. For jobs where memory, bandwidth, and capacity are critical, we've increased memory channels and added support for the new Optane Persistent Memory 200 series. And our distributed asynchronous object storage, or DAOS, delivers exceptionally high bandwidth and IOPS. DAOS in your storage subsystem will unleash performance in your cluster that's been bottlenecked for years. And customers tell us they want more flexibility and control over how CPU cores behave. Only Xeon can deliver 3 configurations in one CPU with our built-in Speed Select technology. We've also introduced SKUs engineered for liquid-cooled systems, combining high core counts and frequencies to power higher-level performance for our most demanding customers. Third-gen Xeon delivers advanced security with Intel crypto acceleration, total memory encryption, and enhanced cryptography processing. And Intel Software Guard extensions enable a trusted execution environment with up to 1 terabyte of available protected space. As always, Xeon-based systems are easy to deploy and optimize, both on-prem and in the cloud, with the development tools you're already familiar with. And thanks to our years of software community engagement, most commercial and open source applications are already optimized to run exceptionally well on Xeon architecture. Now let's take a closer look at performance for one of the most widely used applications in HPC. NAMD is a molecular dynamics code used to help scientists understand how diseases work, so more effective treatments can be developed. In 2020, NAMD developers were part of a multi-institutional team honored with the ACM Gordon Bell Award for outstanding achievement in COVID-19 research. In just a minute, we'll hear from one of those developers on how Xeon optimizations help NAMD perform at its best. First, let's look at the generational performance boost 3rd Gen Xeon brings to NAMD. In this demo, we're comparing two top-of-the-line 2nd and 3rd generation Xeon scalable processors. What you're seeing here is the number of time steps per day that can be simulated by NAMD on each of these systems. NAMD runs significantly faster on 3rd Gen Xeon. That means the scientists using NAMD to explore treatments and vaccines can run more simulations each day for a faster path to discovery. At Intel, we understand the importance of getting every drop of performance out of your hardware and software investments. That's why Intel works closely with HPC partners and engineers to optimize workloads like NAMD for the best possible performance. Here to talk about our NAMD optimizations is Dave Hardy, Senior Research Programmer from the NAMD development team at the University of Illinois, Urbana-Champaign.
NAMD's advanced biomolecular simulations can be a valuable tool for researchers in the fight to develop new and improved therapeutics. With Intel AVX 512 optimizations, NAMD achieves even faster performance on Intel 3rd Gen Xeon hardware. Let's have a look. Here we're comparing two identical 3rd Gen platforms running different versions of NAMD. On the left, we're running the same version from the previous comparison, and on the right, we're running the version optimized for Xeon by the NAMD team in collaboration with Intel, using a tiles algorithm that helps NAMD exploit the potential of Intel AVX 512. Thanks to these optimizations, NAMD is seeing a significant performance boost. Another exciting development is that the University of Illinois has a OneAPI Center of Excellence, and we're using that facility to expand NAMD to support GPU architectures through the use of OneAPI's open standards. This way, we're preparing NAMD to run more optimally on the upcoming Aurora exascale supercomputer at Argonne National Laboratory.
Thanks so much, Dave. Finally, let's see how NAMD performs on 3rd Gen Xeon compared to AMD EPYC. Here we're comparing a 64-core AMD EPYC to a 40-core 3rd Gen Xeon, both running the same versions of NAMD. As you can see, Xeon has a clear performance lead. EPYC simply can't touch NAMD running on Xeon, thanks to our AVX 512 instructions and the optimizations Dave just described. Many of our users are already planning their upgrades to 3rd Gen Xeon, and we're excited to hear their stories about what this latest generation will be helping them achieve. I'd like to introduce one of these customers now, Professor Dieter Kronzmüller, the director of LRZ, to tell us about how LRZ plans to put 3rd Gen Xeon to work.
Thanks, Trish. As you know, at the Leibniz Supercomputing Center, we support groundbreaking science for a wide range of disciplines. One of the ways we do this is by providing researchers with world-class supercomputing capabilities, like our Intel-based SuperMOOC NG system, currently 15th on the top 500, and more importantly, serving hundreds of scientific projects every day. We are proud of the research projects we have enabled, from climate study to research into the formation of our galaxy, to even studying the efficacy of supercomputers themselves. Intel is an important partner in LRZ's HPC practice. As part of our path to exascale, we'll be using the new Intel 3rd generation Xeon scalable processors to power an Intel Deus storage system for extremely demanding artificial intelligence workloads requiring very low latency storage. and we plan to use Optane Persistent Memory 200 to run this Deus system. We are excited to get our new third-generation Intel Xeon system up and running as we prepare the phase 2 of our SuperMOOC NG system. Thanks, Trish, and congratulations on the launch.
I hope this presentation has given you just a taste of what HPC users can expect from Intel's third-generation Xeon scalable processors. We can't wait to learn how this new generation of Xeon will help you rethink what's possible to achieve with HPC to help solve your most complex and challenging problems. Thank you for joining us.